Dr. Imola Kirizsan is a structural engineer specializing in conservation, associate professor at the Technical University of Cluj, Faculty of Architecture and Urban Planning, leader of Utilitas Built Heritage Conservation and Research Center. Always good to put my glasses on. Vice President of Romanian ICOMOS. Our second presenter is Dr. Dorothea Makay, structural engineer specializing in built heritage conservation, founder and leader of Irad M and Kalizid M offices in Cluj, invited lecturer at the UAB and UBB universities. Ladies, please.
Thank you.
Thank you.
Most respected colleagues from all over the world, colleagues from Romania, dear organizer, first of all, we would like to thank you for this opportunity, not only to participate to this event, but also to give a short presentation on what the Transylvanian School on Built Heritage Structural Conservation means since 1991. Actually, this presentation is not only a lecturer, but is also our tribute to Professor Szabó's professional school creating activity that always try to define theoretical, philosophical basis of any, even a practical problem, always trying to read the full picture of the tendencies, first in historic monuments, later in built heritage conservation. Conservation has to be mentioned as the inception of all professional activities related to the Transylvanian Structural Conservation School. Here next to Professor Szabó's name is our architect colleague, co-organizer of the conference series from the beginning, till recently passed away. So first, we would like to put our region in space and time. How you could see in this map, Transylvania and Romania is a particular because how you could see seen on the map, Romania is a country with both Western European and Byzantine cultural influences, with the specificity of these two types of structures. And we would like to put our activity in a timeline from the Athens Charter to the period between 1977 and 1989. It was no institutional system of protection in our area. Thus, in the context, NGOs and professionals of the 90s had to cover up also for state institutions and had to contribute both to educational level and assuring catching up with the international tendencies and philosophies, first of all, through international conferences and publications. We launched also a structural conference in 1997. That conference became international in 1999 after 2 years, the first SACS conferences. And at the end, I hope won't be only the draft. These guidelines for the analysis, conservation, and structural restoration of architectural heritage will be published. Moreover, we believe that the structure hold intrinsic heritage values, not just as support of artistic components. For that reason, I started to show the value and the beauty of the historic structures. The last idea is to illustrate there is the wide-ranging state of decay of many historic buildings in our area, from ruined mansions and manors or churches getting to pre-collapse condition. These slides were designed to illustrate the following aspects. First, the general context in which historic buildings made up of historic load-bearing and non-bearing structure are determined as part of the built environment, including engineered contemporary construction and buildings, and in a smaller extent, historic construction and buildings. Therefore, all the technical legislation designed to engineered building are applied on the historic one as well. The diversity of buildings and structures are determined geographically, functionally, culturally, and as a function of time. But real problem arise with minor heritage or buildings that are not listed or protected by law. They often fall victim to excessive intervention or demolition.
All buildings, regardless if they are old, historic, or new, are made up of the same or at least similar structural subunits using many different construction materials created by the two different structural concepts, empirical intuitive versus engineered one, based on seismic design from the second half of the 20th century. There are foundations, vertical load-bearing structures, slabs, including vaults, stairs, roof structures. Before moving forward, we would like to emphasize in several slides that the historic roof structures, in many cases, with spans over 12, 15 meters, sometimes up to 20, 23 meters, mainly without inner support, are serious, outstanding, unique structures, structural subunits, similarly important as any of the infra and superstructure, therefore have to be research designed for the intervention with the same interest as the other structural subunits forming a building. They are not secondary structural elements, as earthquake standard P103 talks about them, nor supported or non-structural artistic components, as some wooden restorers or art historians may consider them. Worldwide, buildings survived thousands of years, but talking about just our region, a high number of construction have existed for more than 500 up to 900 years. Analyzing these structures, their architectural and technical characteristics, state of decay, detecting their behavior, interpreting the effect of the past actions, natural or anthropic, must be the basis of any kind of structural intervention. It can be observed on the attached diagram, even if Vitruvius's 10 books of architecture or the treatise becoming general in Europe after Palladio's time are the examples of planned thinking. They were based on empirical observations and intuition. Natural sciences gained a momentum in the 17th century and engineering sciences just 200 years ago. Building was always a planned, designed activity, only not necessarily meaning engineered or nowadays earthquake designed. The most important point here is that using modern standards and calculi opportunities, one dealing with historic structure must take into consideration that all these buildings went through a series of real tests of the history, much earlier than contemporary engineering tools have been created. Therefore, in compliance with the ISCARSAC guidelines, understanding the original structure, the way of its mechanical behavior, state of decay, must be considered the very basis of the contemporary research, design, and intervention activity. This has to be also the base for interpreting and calibrating the results of the computer-aided modeling. We can go further, yes. In the opinion of the Transylvanian Conservation School, in the case of historic load-bearing structures, not only the historic material itself, nor the created surfaces or the supported non-bearing architectural or artistic elements represent values to be protected, but also the structural concept as well as the traces of the technologies and technical solutions which resulted in the analyzed structure. This approach stands between two extreme attitudes: restorers approach, when the most important element to be preserved, no matter how, are the materials themselves and the created surfaces. The attitude deriving from the engineer's need to comply all, or at least most of the contemporary building regulations and standards, technically concentrates only on the supported architectural and artistic elements preservation. Not even historic material forming the structure itself, nor structural concept or technology are considered the objective of the intervention. The approach of specialists has evolved with the introduction of modern materials and the increased accessibility of various computer programs. Relevant example is the Church of Bistrica, which reflects a shift in methodology. In the early 90s, the solutions to solve the historical crack involved the use of tie rods. Today, however, the issue could be resolved using high-quality materials. The two hazardous extreme attitude must be avoided are: it stood for centuries, it will stay for the future, incorrect, respectively. The safety can only be guaranteed if all contemporary standards are respected. But we could quote the St. Bernard Filden quote, what already Professor Kirizsan showed you. The following several slides are showing examples of working, empirical, intuitive structural concepts that are not according to contemporary regulations. The shallow foundation made of dry masonry are the historic solution not only for wooden vernacular houses, but also for timber churches or bell towers. All these elastic structures do not present a hazard for local settlement. An extreme case was the 30 centimeter deep masonry foundation of the Arpadian church in Sikh that survived 700 years, naturally with damages, so underpinning was inevitable, but still remarkable as a historic solution of shallow masonry foundation set originally on stabilized clay layers. The Baroque Roman Catholic Episcopal Palace in Oradea is outstanding from many viewpoints. Here we just mention two aspects: 3 levels of transversal walls in many axes do rest directly or through just arches on the cellar's masonry vault for almost 300 years without visible damages. Longitudinal external walls of the corridors are not connected with transversal walls to the rest of the structure for more than 20-meter length, another conformation not complying at all with actual regulation. The vaulting system of the Gothic, especially whole churches as well as the timber slabs, have no required horizontal diaphragm roll as well.
So the historic roof structure are not treated correctly. It's not modeling all the time, but also we have to follow the fire regulation often in order to mark a job that has been done. Fireproofing is applied to the wooden elements. Those destroying an intangible value of the roofs, inscriptions, assembly marks left during surface preparation. A solution could be to make the fire calculation using Eurocode 5. And I have another question. If we are doing the proper restoration work, is applied or not to be open for the public? And if you are doing a new structure in the roof, they have to be different than the original one.
Sorry, I can't go back.
Slide before, we shown a couple of examples
here
from Brussels, from Paris, and also from Lutheran Church in Bistritz. I want to do a very thin metallic structure for public, for visiting, like in a Brussels roof, but our regulation not really lets to do it. And as the final example, I'm showing two different examples. Everybody knows the shelter floor ruin made by Zumthor, and we would like to copy this structure and put in our roof as a visiting platform, but unfortunately, after our regulation and calculation, we will have this kind of structure. And at the end, some conclusion, and I would like to underline, then Romanian expert must be relieved from responsibility on not applying all paragraphs of all standards created to support engineering design of modern contemporary structure when dealing with empirical intuitive structure. A solution that could be to increase the role of ISARSAR guideline and of the other ICOMOS charter in our country to be taken into consideration and basis for specific technical regulation for built heritage. Otherwise, historic load-bearing structure as intrinsic part of the historic building will result in loss of values or either to under or over consolidation. Thank you for the attention, and I would like to share with you our teams, Professor Sabo